Struggling with a slow and unreliable line follower? I've been there too. In this video, I've compiled all my experience into 8 key upgrades that you can do to make your line follower super fast and smooth. Since I want to keep this video brief and easy to follow, I've added a free PDF with detailed steps linked in the description. Before we dive into the upgrades, let's take a quick look at a basic line follower. It uses two IR sensors to detect the line and send that data to an Arduino, which processes the data and drives the motors through an L298N motor driver. Based on this setup, I've broken the upgrades into two main categories. The first five are hardware upgrades, and the remaining three are software enhancement for fine tuning. Together, these upgrades will make your robot a faster and more reliable line follower. Upgrade number one. In my early projects, my line follower often missed turns and oscillated a lot. This was mainly due to insufficient input data. It can be fixed by using a sensor array of at least 5 sensors. But even with the linear sensor array, the robot sometimes jumped off the track at higher speeds. To improve line detection and better curve handling, I recommend using a curved sensor array. For simpler application, the QTR8RC linear sensor array works well and easy to use. More details in the PDF. Upgrade number 2. Once I had precision covered, my next goal was speed. Initially, I thought adding more motors might help, but using more than two motors actually hurt performance. I found out that using high quality, high performance motors like the N20 microgear motors works best for line followers. Depending on your needs, the N30 or 37D motors also performs well. Good motors need good drivers. I moved from the L298N to better drivers like the TRV8833 or the TB6612FNG. These drivers offer better control and higher power efficiency. They are also more compact, making them ideal for line followers. Upgrade number 3. In one of my earlier competitions, I learned the hard way that reliable power is crucial, no matter how good your motors and the sensors are. Switching to high capacity, lithium polymer battery made a huge difference. Lithium ion batteries are also good, but lithium polymer batteries offer better performance and lower weight. Choose the voltage based on your motors. But reliable power is one part of the equation. The next upgrade really ties everything together. Upgrade number 4. One of the biggest challenges I faced was ensuring stable operation of the robot when adding complex functions. Sometimes the motors draw significant power, causing the Arduino and the sensors to malfunction. The key was to integrate multiple step-down voltage regulators to manage power distribution effectively. This setup prevents issues from battery voltage drops, maintaining constant motor voltage. Some great options for step-down voltage regulators include the LM2596, MP1584EN, and XL4015. More information in the PDF. Upgrade number 5. With most of the hardware upgrades done, this final one is about bringing them all together into a stable base. One of the best decisions I made for my line followers was switching to PCBs. Using PCBs instead of jumper wires and breadboards significantly reduced signal noise, making my line followers more reliable and robust. To complement this new setup, I moved away from the generic chassis design. I opt for custom laser cut design, 3D printed parts, and sometimes I even use the PCB itself as the chassis, which ensured lower center of gravity, balanced weight distribution, and better aerodynamics. These upgrades made my line followers into more stable and high-speed robots that excelled in competitions. Now that we have a reliable base, we can fine-tune it through the code. So, let's move into upgrade number 6. To get a super smooth motion out of your line follower, implementing this simple yet highly valuable code is crucial. It's called PID control. PID stands for proportional, integral, and derivative. This feedback control system allows your robot to self-adjust to the track with a fewer lines of code. You can find an example code with more details in the PDF. Like this video if you want an in-depth tutorial of how I make a super speed line follower step by step. Upgrade number 7. Now we are optimizing the robot to reduce its error chances. Sensor data can often be noisy due to environmental factors and different lighting conditions. To make it more reliable, we can implement a filter. For projects like this, a simple moving average filter works well. To ensure even more accuracy, calibrating the sensors is a key. You can easily calibrate the sensors using libraries like the QTR, which will also help the PID implementation process. We have now done all the important upgrades. The eighth one is a bonus. Upgrade number 8. I'm just going to briefly mention the improvements. Feel free to play around with these ideas and see what works best for your specific setup. Number 1. Predictive path planning. This uses algorithms to predict the path ahead and adjust the robot's movement to smoother turns. Number 2. Dynamic speed adjustment. This allows the robot to change its speed based on the path. It can slow down on sharp turns and speed up on straight paths. Number 3. State machine for control logic. This helps manage different states of the robot, like straight lines, turns, and junctions, making the control logic cleaner and more efficient. Just like before, more details and example codes can be found in the PDF. Thank you for staying till the end and see you in a future video.